In this lesson, we're going to review working with integers, adding and subtracting, multiplying and dividing them. I know that on my screen it says integers and powers, but I think what I'll do is, there's a fairly long note, so I'm just going to focus on the integers part in this video, and I'll do a separate video focusing on the powers part. So let's just jump right in. Integers are something that you should have learned about, or at least done a bit of work with before now. So this should be review. So integers are positive or negative whole numbers. So they can be positive, they can be negative, but they have to be whole numbers. In other words, there's no decimals involved in integers. To add or subtract integers, what starts to get a little bit more confusing when we're working with integers is the fact that they have signs. If everything's positive, you're probably all experts at working with things that are all positive. But once we start throwing negatives in there, either having two negatives or combining negative and positive, things get a little trickier. So here's a few techniques that we can use to help make it less tricky. Method 1. First, we can add up the numbers if they have the same sign. So if they have the same sign, they're both positive or they're both negative, or if there's more than two, if they're all positive or all negative, then just all we have to do is add them all up. So looking at some specific examples, we know that 2 plus 4 equals 6, and we also know that if they're both positive, it's going to be positive overall. In the next one below it, they're both negative. So let's ignore the negative signs for now, and again we know, pardon me, a lot of allergies. We know that 2 plus 4 is 6, so if we focus on, again, the 2 plus 4 part, it's still 6, of course, but if they're both negative, then we can just put that same sign in front. So we're adding, but then keeping the sign. But that only applies if they're all the same sign. Here's another one that has all the same signs, so we can just go 2 plus 4 is 6, plus 7 is 13, and then throw that negative sign out front, since they're all the same. So that's a good one for if we have all the same signs. If the signs are different, then one thing we could do is we could subtract the smaller number from the bigger, whichever one it is. Whichever one's, it doesn't matter which is negative and what's positive, but we could just take the smaller away from the bigger and then keep the sign from the bigger one. So I see I've got two different signs here. I've got a 10 and a 15 as my numbers, negative 10, positive 15. So let's subtract the 10 from the 15, and we should recognize that that's 5. And then look at the signs. The bigger one was the 15, so that would be a plus 5. And you know that if it's positive, I don't have to write the plus sign down. That's assumed. So I could leave that plus sign out if I wanted to. Again, we got two opposite signs. And again, we don't always see plus signs written down. So this is assumed to be a positive 20, but we don't see that written. So we got two signs, a positive and a negative. Let's subtract the smaller from the bigger, so 25 minus 20 is equal to 5. But the bigger one is the negative. The 25 is the negative, so we'll take that sign from the 25. So that's, again, another technique to help make things a little easier. Another way we could look at it is to use number lines. Number lines can be used to add or subtract integers. If we are adding something, if we got a positive number, we're going to move to the right. And if we have a negative number, we're going to move to the left. So if we were to look at 3 plus 4, then we'd start at 3. Whatever our first number is, that's our starting place. We're starting at 3. So we find 3 on the number line. And then plus 4 is saying go 4 steps to the right, because positive moves to the right. So again, I got this, I'm starting at 3, I've circled that in red, and I go 1, 2, 3, 4 to the right because of the positive sign, and I end up at 7. Okay, for the next one, we've got negative 3 minus 4, so we're starting at negative 3, so that's here, and it's a minus 4, so we're going to go to the left. Starting at negative 3, I go 1, 2, 3, 4, and I end up at negative 7 in this case. We can combine positive and negatives just like if we're not using the number line, but it's always the same technique. Whatever number comes first, that's where we start. Negative 4 is where we start. And then from there, if it's positive, I move to the right, as it is here. 1, 2, 3, 4, 5. Notice how we crossed over from negative numbers to positive numbers. We went past 0. That's not a problem. Number line, nothing changes on the number line, or because we're doing that. We just, where we end up is what our answer is. And so our answer is 1. Another thing that causes people problems sometimes is if we've got combining signs. That's what I call it, combining signs. So double signs, sometimes we'll see them side by side, but sometimes we'll see them, if we're multiplying or dividing, we won't see them side by side. So when you hear me talk about combining signs, put that in a nice pink color, then we have to know how to combine them. So 2 positives make a positive. 2 negatives also make a positive. A positive and a negative make a negative. A negative and a positive also make a negative. One way to remember this is that any time we combine 2 of the same signs, it's going to turn out positive. Anytime we combine 2 opposite signs, and we're only ever talking about combining 2 signs together at the moment, 2 opposite signs, 2 different signs, when I say opposite and different, it's the same thing, because there only are 2 choices, then we're going to get negative. So if we're adding or subtracting, like we are in this case, we are going to see the signs side by side, often with brackets around them. So what I need to combine here is these 2 signs are side by side. We need to simplify that down to a single thing. So we have 2 of opposite signs, so it's 2 minus 3. Now we can use our technique. We can use the number line, or we can use the other technique. For these ones, maybe I'll just use the other technique because it's easier, and I don't have to draw out a number line each time. So opposite signs, 3 minus 2 is 1. Taking the sign of the bigger one gives me negative 1. Here we have 2 opposite signs side by side again. So then I've got negative 3 minus 5. So I've simplified first. Now I've got 2 of the same sign together, right? Negative 3 and negative 5. But this isn't a combining signs thing. This is just a working it out, because they have to be side by side. And so in this case, I'll add them together and take the sign of the bigger one. Here we've got 2 of the same sign side by side, and so I got negative 9 plus 7. And then for the next step, as far as combining them goes, they're opposite here, opposite in the second line, so I'll subtract 7 from 9, I get 2. The bigger number is negative, so I'll put the negative sign out front. 2 of the same sign, 3 plus 5, so I just add them together and they're both positive, so my answer is positive. 2 opposite signs, so the negative 9 doesn't change, but I have a negative 7, and then now adding these together, or subtracting if you prefer, they're both negative, so I have 16, and I put the negative sign out front. So I'm following very specific rules, and throughout the course I'm always going to be following the rules of math. I never do anything random, so to speak. It's always following the rules of math, and so I'm going to keep referring to that. There's one more. When there's one more time, when there's more than one addition or subtraction operation to be done, work from left to right. Okay, we always in math work from left to right. if there's more than one thing going on. So in this one, first thing I want to do is I always look to see these signs, simplify those. So I'm going to rewrite it with simplified signs. Those two of the same sign become positive. Now, in this case, I could do it step by step, or I could just see that I've simplified the signs, and so since they're all the same sign, I can add them all up. 3 plus 6 is 9, plus 9 again is 18. Since they're all positive, that would be my answer. When this rule about working from left to right is more important is when we've got operations involved. So the operations involved in this example are all just plus, they're all equal. But when I've got multiplication or division or adding and subtracting mixed together, then order of operations, as you know, starts to become more of an issue. The same rules for combining signs applies if we're multiplying or dividing. So again, if we've got two of the same signs, plus plus becomes plus, whether we're multiplying or dividing. And negative negative becomes a positive, whether we're multiplying or dividing. So same signs, again, become positive always. Opposite signs, whether we're multiplying or dividing, it doesn't matter in which order, they become negative. Signs equals negative. The only difference is where we look for them. When we're doing adding or subtracting, like here, the signs are beside each other. Those two minus signs that I've highlighted in green are basically beside each other. They got a bracket in between them, but they're beside each other. When we're multiplying or dividing, you're not going to see that. You're going to see a times sign or a divide sign in between them, but we still have to simplify the signs. So here we have positive 2 times negative 3. The signs aren't beside each other. We just have to know that because of the multiplication, we have to combine the signs. So again, we can just think, okay, well, 2 times 3 is 6, and then worry about the sign. What was the rule if I had a positive and a negative? Oh yeah, it's negative overall. If we have brackets like this one, that means multiply, so that means the same thing. Again, we've got a positive times a negative. That 6 is assumed to be positive. I can still just multiply the 8 times 6 first if I wish to. I know that's 48, and then worry about the signs. Again, I've got a negative and a positive. One of each always combines to give me negative. That slash for this one means divide. We got a negative and a positive that's assumed to be there. 64 divided by 8 equals 8, and opposite signs always mean negative. 27 divided by negative 3, positive, negative. 27 divided by 3 is 9. Opposite signs always mean negative if I'm just dealing with two of them. Oh, I see that there's some that I didn't see on my screen before, so I'll come back to them. Here, again, it's multiply. Pardon me. And positive times negative times negative is positive overall. 7 times 5 is 35. So it's plus 35, but once again, not necessary to write that plus sign down. It's understood to be positive. Negative divided by negative, same thing. 12 divided by 12 is 1. Two of the same signs make it positive overall, but I don't have to write the plus sign down. It's assumed to be positive. If we have a combination of things, then we just take it in stages. Let me just, for fun, throw something out. What if I had, 9 divided by negative 3 times 2. So again, this is just getting a couple things tied in here. First of all, I go from left to right. So I need to deal with these guys first because that's the first operation from left to right, and divide and multiply are equal. when I look at that, I've got a positive 9 assumed and a negative 3. So 9 divided by 3 is 3, and positive divided by negative, two opposite signs, is negative. So it turns out to be a negative 3 there, and I still have the times 2 from before. Now I've got a negative 3 times a positive 2. 3 times 2 is 6. Negative times positive, again, is negative. So my overall answer for that one would be negative 6. So that's just a little example of how we can combine more than two integers. And we'll see more examples as the course goes on. So try the homework. I'm going to stop there, and I would like you to work on the practice for integers now, and then we'll come back and do the powers next.